Now let's formally define what software engineering is. Software engineering comprises of these two sub-definitions. First of all, it's an engineering discipline. Engineers make things work. So when you become engineers, you're going to apply the principles, the policies, the theories, the skills, the tools, whatever you have used in order to build products. And you are going to work within the time, within the budgetary constraints your client has given you. So that is why software engineering can be called as an engineering discipline, because engineers make things work. Engineers solve problems. The second sub-definition of software engineering is it covers all aspects of software production. Software engineering is not just about writing code. It's about getting the requirements. It's about designing. It's about coding. It's about testing. It's about putting your project in place. It's about deployment. It's about maintaining. Not just that. It's about financing, how to handle finances. It covers all the software management phases, not just coding. So it is kind of an umbrella for software production. So these two sub-definitions make, we can use these two sub-definitions to formally define software engineering. Engineering is, all about getting the results without compromising quality, but within the schedule that has been defined by your client and within the cost. Why do we need software engineering? Why is software engineering so important? Why can't I just write code like I used to always? Why do I need to apply these techniques? The first reason for this is reliance on advanced software systems. So more and more individuals and the society itself relies on advanced software systems. So we need to be able to produce reliable software quickly and economically. Second one, it's usually cheaper in the long run. Now, when I talk about specification, talking to the client, getting the requirements, refining those requirements, designing, refining that design, sounds like a headache, right? But in the long run, most of your cost for development is almost always incurred during the maintenance phase. That is, once the product is deployed. Because development goes on as planned, maintenance is really unpredictable. You cannot predict what kind of bugs the software it can throw, especially when it's deployed on field. You cannot predict how the customers or the client's mind is going to change. You cannot predict what new emerging technology is out there in the market. So most of it is going to come, the cost part of it is going to be the maintenance phase. That is going to be the costliest phase. Now suppose I feel applying software engineering tools and techniques and drawing the the diagrams, the overview, the system specific architecture, the overview or the high level architecture, it's time consuming, and I straight go to code from scratch. Later, when I have new requirements coming in once I've deployed the software, it's going to be really hard for me to incorporate or integrate those updates into the existing software because I have not used any software engineering tools and techniques to build my code. So eventually I'll have to break down the entire thing and start writing things from scratch, which is going to cost me 3-4 times more than the product if it was developed using software engineering standard practices. So these are the two important reasons why software engineering tools and techniques, even though may sound boring now, even though it may sound time consuming now, this is definitely going to help you in the long run when you take up a job as a professional software developer or as an entrepreneur. Now, let's see what is a software process. I told you software engineering is a set of activities, a systematic approach to develop a software. So such a systematic approach that is employed in software engineering is called as a software process. So software process is nothing but a sequence of activities that will ultimately lead you to the production of the final software products. Let's look at the 4 major activities that are involved in a software process. Let's talk about the first activity. I think I've briefed you about these activities informally through this class, and we are going to have an entire module that will focus on each of these activities in detail. Let's just give you an overview. The first activity in a software process is software specification, where the customers and the engineers define what the software should do, what are the objectives of the software, why they are building the software, what are the goals of the software, what is the outcome of the software, both functional, non-functional, and so on. Not just that, they're also going to define what are the budget, time, and other constraints within which the software should be developed and the software should be used. That is the first phase. The second phase of software process is software development. So here, the software engineer is going to actually first design the software, all the modules, a high-level design and a very specific module-level design, and then write the code for the software. The third step is software validation, where you can see in step 1, the customer has given you all the requirements and the constraints, and you have made a software specification out of it. Now, in the second phase, your software is developed. You're going to quickly check if whatever software you have developed works according to the requirements or matches all the constraints defined in step 1. So you're going to take a software, give it a variety of inputs, check the outputs, see if all the outputs that are defined as requirements are covered, check whether the budgetary, the cost, the time, and any other functional and non-functional constraints are all incorporated in your software. If not, you're going to repeat the cycle again. And the last one is software evolution, where your software is going to be modified as many times as needed to incorporate new technology, new customer needs, new market needs, and so on. So these are the 4 important activities of a software process. Do not worry about the detailing. We're going to take up each of these activities and study it in, at a very extreme level of detail in the next chapter. Different types of systems have different development processes. For example, if I have a software system that is going to be developed for an aircraft, then I should make sure that software specification is in place even before I start with development. I cannot have a software specification which I'm not sure of, which is not thoroughly understood, which is not thoroughly refined, and then go into development, because it's a mission critical system. Consider an e-commerce website like Amazon or Myntra. I can have the specification and development happening side by side. As and when I feel studying the market that these new modules can be added to my e-commerce system, I can always go back to the specification, add, alter, and develop additional modules. It cannot do it with an aircraft, a software that controls an aircraft. So different types of softwares will have different orders, or will define actually how your software process activities are sequenced. Generally, this is the sequence, but you for certain types of products, you may have some phases happening simultaneously, and for other types of products, you may follow a strict sequential order. Now let's relate software engineering to computer science and systems engineering. Okay, computer science, what you're going to learn throughout the course of your BE, is concerned with theories, methods that underlie computers and other software systems. It's more skill-oriented or theory-oriented. Software engineering, on the other side, it's about how you apply these theories to solve problems. Software engineering may not teach you how to code. Computer science will do that for you. But how to apply the coding skills you have learned to build a robust software, to build a working software, to build a software that keeps your customer happy. Software engineering is going to help you solve these practical problems. Let's go to systems engineering. System engineering is actually concerned with all parts of development and evolution. System engineering will also be concerned about hardware deployment. What are the hardware features and functionalities or components that you need for your software, and how those hardware components are going to interact. Even that is considered in system engineering, along with computer science, along with software engineering principles and theories.